Hello, and welcome to today's webinar, Web and Mobile Architecture with Architecture Dashboard, the second session in our in-depth Tech Talk series. Today, we'll be discussing best practices around creating your OutSystems web and mobile applications and how to use the Architecture Dashboard. To discuss these topics, I'm delighted to be joined by the extremely knowledgeable Francisco Menezes, Director of Developer Advocacy and Evangelism at OutSystems. I'm Christina LeBlanc, Manager of Global Programs, and I'll be chairing today's discussion. Before we go further, a quick word on housekeeping. On your screens, you'll see a Resources tab, in which you will find helpful links that support today's presentation. On the center of your screen, you will see the slides and live demo. The size of this window can be adjusted by each attendee by dragging the corner of the window. Finally, please note that this session will be available on demand and sent to you via email from On24 after the live section. Now that we've covered housekeeping, over to you, Francisco.
Thank you very much, Christina. I'm going to talk about our architecture design methodology and how we support it with the Architecture Dashboard tool. My name is Francisco Menezes. I joined OutSystems back in 2002, and I have been enabling and promoting best practices in OutSystems application design ever since. For a while, I managed architecture and development practices that originated most of what you will see today. Currently, I'm a Developer Advocacy Director in OutSystems, very much worried in taking our best practices to all the low-coders around the world. My first question is, why should we even trouble with architecture? If we ignore the architecture side of our applications, we'll eventually reach what we call a spaghetti architecture after a period of time. This results in several issues, being the main ones: poor service abstraction. Services around core business concepts are not correctly isolated and abstracted. That means that business rules are spread over different systems and code reuse becomes very little structured and even possible. The second aspect are the unmanageable dependencies. System components are not correctly isolated from each other, so updating or replacing a system has a snowball effect on other systems. The third aspect is around inflexible and slow-moving legacy systems. Quickly adapting a legacy system to business changes is difficult. If the system is complex and inflexible, changes can take a long time. Sometimes the technology is obsolete, and the accumulation of core information and system dependencies over time can hinder any replacement. Architects just hate spaghetti. So why is architecture design important? To drive consensus among all players, to support planning, to facilitate change, to manage complexity, which in overall will reduce risks and technical debt, which is the end game. These are the topics we'll cover in this session. You'll get to know the canvas and how to use it to leverage your architecture design. You'll learn the design process and we'll follow an example. Then we'll see how to validate the designed architecture and get to know the architecture dashboard and see it in action, analyzing our architecture and helping us fixing it. We'll wrap up with the main takeaways from this talk and finish with Q&A. Let me introduce the Architecture Canvas, which is a framework to support application architecture design that we follow in OutSystems. The Architecture Canvas is a multi-layer framework that provides a systematic approach to speed up architecture design. It promotes the correct abstraction of reusable services and components, maximizes independent life cycles among all parts of your architecture by setting the correct dependencies among each other, and finally, it minimizes the impact of changes, making it much easier to maintain and evolve your architecture. The bottom two layers is where you're going to isolate all the reusable services or components. The foundation layer will hold all reusable non-functional modules, which are business agnostic, such as connectors to external systems, or to extend your framework through libraries, reusable UI patterns, themes, all sorts of non-functional requirements like an audit trailing. And on top of that, you will implement your core business services, that is, services around your business concepts, with all its business entities, business rules, business transactions, and business widgets. These services should be system agnostic and they should be based on foundation services to abstract any integration detail that you might need. Finally, on top you have the end user layer, where you will support all your user interactions through your user interfaces, user processes, reusing the core and foundation services to support user journeys, but they should never provide services to others to ensure lifecycle independence. Now you might have come across a fourth layer, because in the past we used to have 4 layers, that is before OutSystems 11. So you deserve an explanation why we are no longer talking about the orchestration layer. The fact is that cross-application orchestration was necessary because destinations, that is hyperlinks across end users, which is a common practice in the web experience, were treated as strong dependencies, hence creating undesired dependencies across end user applications. This layer meant to isolate process dashboards and portal home pages, mashing up information from different applications to provide a unified user experience and keep applications independent. So we would isolate in the orchestration layer everything that had to navigate across several end user applications or modules. If you are starting with OutSystems 11, you can simply disregard this layer and ignore destinations because they are no longer considered in the architecture analysis. How does it look in OutSystems architecture inside your enterprise landscape? Most probably, OutSystems is just another technology in your IT ecosystem, and you need to integrate with other in-house or cloud-based systems. Using the canvas, you will have the integration services, which are merely technical wrappers to external producers, normalizing data structures and abstracting integration complexity like error handling, authentication, etc. And they should not have any business logic. At this level, they are just wrapping up an external system that itself contains business logic. Then you implement all your non-functional requirements with non-business functionality reusable across any business domain like an audit trail, UI pattern, style guide, Google Maps. So these are components that will support any type of business application. On top of these, you will implement all your reusable core functionality around core business concepts with all the business rules, business transactions, and business data. And you can provide APIs to external systems that again are simply wrappers to your internal core services, translating those services to the agreed contract with the external system. And this can be done to REST, SOAP, or any other type of API. Finally, on top, you will implement all your applications that will serve your internet and extranet users. Now that we have seen the architecture canvas that we use to build our architecture in OutSystems, let us now see how we can validate if our architecture is sound. We should follow a set of basic guidelines. The first rule is no upward references across these layers. An upward reference tends to create a cluster where any two modules directly or indirectly have a circular dependency. For instance, module B can reach module A indirectly, but module A can also reach module B indirectly. So we have a cluster of interdependent modules. And the worst is that, for instance, in this example, if you have another end user module, let's call it end user 2, that is legitimately consuming the core service B, it becomes dependent on this entire cluster. Not only its runtime will get an unnecessarily large footprint, but it will also be constantly impacted, that is outdated, with changes made in modules that it should not even be aware of. End-user modules should not provide reusable services. This ensures that they are correctly isolated, allowing them to have different life cycles, that is, different versioning paces set by different sponsors or project teams. For instance, if end-user 1 consumes end-user 2, not only it can be independent from end-user 2, but it also cannot be independent of the remaining of the hierarchy below it. Finally, the third rule is that we need to avoid cycles among core modules or foundation modules. If we follow the previous two rules, we don't need to worry about cycles among end-user modules. A cycle is always undesirable since it brings unexpected impacts and hard-to-manage code. A cycle between modules indicates that the concepts are not correctly abstracted. As you can see, these three Canvas rules are quite simple to understand and memorize, and we are just adding two extra recommendations. And the first one is that the core modules should not have front-end screens. And this is very common to happen. For instance, if you're implementing some service, you might want to add some screens just to make unit tests. But as a developer, once you tested your code, you should get rid of the test screens. If for some reason those test screens are useful to support any kind of regression tests or some BDD testing, they should be removed from the core module and be placed in an end user testing module. One of the main dangers of keeping test screens on your core modules is that they tend to be anonymous screens just for testing purposes, but if they end up in production, they can open up a security breach. The second recommendation is that all your entities should be exposed read-only to make sure that you are not allowing consumers to directly use the CRUD actions to create or update or delete records in the database directly, because the core service should abstract the business transaction. It should worry about any kind of validation, normalization, any kind of side effects like auditing or integrating with another system or whatever. But make sure that you implement all your business transactions as public actions, for instance, to fully abstract the core module and have a safe service exposed to other consumers. At the foundation layer, you need to avoid business logic. Sometimes people tend to implement business rules at this layer, but this layer needs to be business agnostic to make sure that it can be reused in any domain of application. I'm not expecting to find core business entities at this level. For instance, if you need to create a generic service to audit all your transactions, you will create an audit entity, but that entity is not a core entity. The audit itself is not the business of your company. The business of your company is selling a product or provisioning a new customer or changing some contract. The audit itself is just a service to support your application. So we have been talking about the Canvas layers and how to handle modules inside those layers. What about applications? Well, before going over the application composition, it's important to understand what is the meaning of application in this context. So an application is a set of modules defined in Service Studio that constitutes the minimal deployment unit for lifetime. That is, in lifetime, what you promote from development to quality or quality to production are applications, not single modules. So in this context, an application is a deployment unit. It's not the concept that the business normally has about an application. Now, how do you define the layer of an application is by simply looking at the topmost module inside that application. If the topmost module of an application is an end user module, then this is an end user application. If the top is a core module, then this is a core application. Or if the top is a foundation module, then this is a foundation application. So with applications into place, what are the rules for a correct architecture? Rule number one is just to apply the principles on your modules. Everything I spoke before. Once you made sure that your modules are following all the rules, you can go after the applications. The same principles just apply here, but considering references across applications. Let's look at an example. Just imagine that you're doing your first project and you end up having an end user module plus two core modules and a foundation module, and everything is perfect in terms of module architecture. And you want to deploy this, so it's natural that you package everything together into the same end user application. Now you have a second project with similar constitution and everything is okay in terms of modules, and you package it in a second application and you're set to deploy it. Now, what happens if in a third project or even during the second project, you decide to reuse this core functionality, which is licit? There's no issue regarding modules. This is a perfectly sound reference. It's a downward reference, but in terms of application, now you create a side reference across two end-user applications. As you know, this is undesirable because now I cannot deploy end-user application 1 without having to bring end-user application 2. So end-user application should not provide services to other applications as stated before. We should isolate a common core application with the common core and foundation services that will now support both applications. Before we add this relation, everything was just perfect, because if you look at this, you don't need to split the applications in several applications as long as these cores are going to serve only inside this application. But the minute you want to share something, you should always try to isolate common modules in common applications. The third rule states that you should not mix owners. Having more than one owner for an application results in complex deployment management, as accountability for what has been changed becomes unclear. Promoting ownership is key. If it is not possible to concentrate the ownership of an application, consider splitting it in such a way that ownership is clearly defined. The fourth rule is not to mix sponsors. The same way we don't want to mix owners, we should not also mix sponsors, because they have different demands and different paces. Let's imagine we have a portal that allows executing simulations over different insurance line of businesses. If all the line of business are under the same application, any change made to the auto business cannot be released independently from the other line of business. So the slowest line of business will dictate the release cycle. By creating independent applications per line of business, each one can determine the pace of its own deliverables. And of course, now you identify whatever is common that needs to be governed together. And in this example, there's an extra end-user application that will probably belong to a different sponsor, like a marketing department. Now let's follow the process of designing an architecture following the Canvas principles. It's fundamental that your architecture is aligned with business goals. Business must orient architecture. Only by translating business needs and concepts, the architecture will allow us to evolve and scale up with business, while ensuring independent life cycles between different lines of businesses. The first step is to disclose concepts and needs. Disclose business concepts, integration needs, and non-functional requirements. Business alignment is achieved by identifying relevant user stories for each role, either by analyzing some documentation or simply by having a conversation with business stakeholders. Another important source of information is to identify the information architecture recognized by business users. Again, either by talking with them or by analyzing an existing system that you're going to augment or replace. It's important to get the right names and hierarchy and match the navigation patterns with user expectations. We need to understand the integration technology that will be involved in the project. It's important to disclose unknown features of the involved technology, for instance, what type of APIs, if they are stateless or not, if the communication protocol requires custom certification, etc., etc. Finally, user experience is key to manage expectations. Things like accessibility requirements, what type of channels needs to be provided, is this a mobile-only application or different roles require different channels, etc., etc. It's important to get as many concepts as possible, and I'm talking about high-level concepts, because of course you will disclose more concepts as the project progresses and details are found. But missing major concepts might compromise the future of your applications, leading to complex refactoring later on. The second step is to organize the concepts that you just discovered in the canvas. Actually, you don't need to first discover everything and then organize those concepts in the canvas. You can execute both steps iteratively. But the idea is that the canvas will help you organize the concepts by nature. Whenever you identify user activities or user processes, then you place those concepts in the end user layer. Every time you find a business concept, you simply place that concept in the core business layer. Every time I identify some integration need, like I need to integrate with an ERP or a certain CRM, or I have some non-functional requirements, I need to audit all my business transactions, or I need to support the style guide of my applications, all those concepts belong to the foundation layer. Keep in mind that I'm talking about concepts, not modules or application artifacts. Only on the third step, I will start assembling concepts into application modules following recommended architecture patterns. Let me summarize what are the assembling principles. Once you identified all the concepts, you should join concepts if they are conceptually related. As a small example, order and order line, those are related concepts. Another example could be customer and customer address. The second principle is to avoid joining concepts even if they are related, but if they have different life cycles. A good example would be like a customer and the customer contract. They are related. You might want to join them to be implemented in the same module. But what if you have consumers of customers that don't require any contract information or contract rules? The contract itself should evolve independently from the customers so you don't impact the consumers of customers that don't care about contracts. The third rule is to isolate reusable logic from old integration logic. That's an example that you can see in this pattern where my master data for customers comes from an external ERP, but instead of putting all my customer related logic in a single module, I'm isolating the integration logic from the abstraction that I'm building, and thus protecting it from changes from the external system. And finally, you should apply known design patterns. Unfortunately, we will have no time to go through a lot of patterns, but I will recommend you some documentation around known design patterns. Now, the idea is to keep iterating these three steps because, as you can imagine, the architecture is not closed up front. You need to refine the architecture as you disclose new concepts and more detail is revealed during the project. Let us follow an example to see how this works. We will follow a sample architecture design process for an hospital-related scenario. Let's design an application to manage doctor appointments in hospitals. As we are disclosing and organizing, we just found out that these are the end-user processes that we need to support. We need to allow doctors to see the agenda, to see the exams of their patients, and to select urgent cases. The doctor itself is a core business concept that will have to be represented in our system. Of course, we need the concept of an exam. The exam relates to a patient, and doctors work in different units from different hospitals, so we need to represent those concepts. Finally, we have the concept of an appointment, which is actually a concept that will be based on all other unit concepts. An appointment will happen in a given hospital with a doctor and a patient, and it should also have a time slot among some additional information that will be represented inside the appointment. The application will need to interact with Google Calendar just to represent appointments and find the availability of doctors, but also with SMS notifications to notify doctors of appointment updates. We also need a web application to support creation of appointments. This can be handled by a planner. Next step is to go over the assembling process. Note that only now we are going to think on how these concepts will translate into modules and dive into the technical side. First, looking at the doctor processes, they can live together in the same mobile application because we don't need to have separate life cycles for these processes. So we will assemble those three concepts into this doctor application. This is going to be a mobile application. The exams and related services will sit in their own module, which will be a core service module. I'm using some naming convention using some suffixes that we typically propose to distinguish the nature of the modules. So CS stands for a core service. Same thing will happen with the doctor and related business subcomponents, and we created Doctor CS. Patient records and their contact information will sit in their own module. Here's an example where we are going to merge two concepts into a single module. Units are related to hospitals, and it makes no sense to deal with units without hospitals, so this will become the hospital core service. Appointment becomes a business logic module, orchestrating the core service below it. The naming convention business logic BL in this module is to show that this is more than a simple core service. The business logic here is the result of the composition of the more unitary services below, and it will support most of the business rules of the doctor application, so it's not so much reusable by other applications like the other core services. Since the doctor application is a mobile application, we will also need A mobile core service, and the MBL here stands for Mobile Business Logic. Why am I creating this separately? Well, everything else is server-side. This is going to support all the server-side operations, but given that the mobile application will have its own local repository, we are creating this specific module to handle the synchronization of information and to support all the client-side logic. Why am I calling this Doctor app? Obviously, connecting this directly to this Doctor app. The main reason is that this kind of mobile modules, they should not be reusable by other mobile applications. And the reason is that the mobile application should be optimized for its requirements. Most of the times, if we try to create a local representation that copes with different applications, we'll end up having a mobile database model that is too generic or has useless information for certain applications. And keep in mind that the client-side logic will run inside the device, which has limited resources. So it's always a good idea to create specific logic for specific applications. Along with SMS notifications, a good way to contact doctors can be through push notifications, and for that we can use a plugin that exists on the Forge. The Google Calendar and SMS notification modules provide the functionality to access the calendar and to notify via SMS. This is done through integration services on the server side, so web applications can also reuse this. Finally, we have the theme modules. One for the web application and another one for the mobile application. These are all the modules that have been identified as part of the requirements. What about application composition? If we make use of the 4 rules of a good lifetime composition, here's one possible outcome that constitutes a sound architecture in terms of applications. So if you see the relations across applications, they are all downward relations, and we optimize the independent life cycles. For instance, remember that I mentioned that this doctor application mobile business logic should be exclusive to the doctor application, so it's packaged together because it's not going to be consumed outside the doctor application. Here the option was to gather all the core services in this hospital core services application. Remember that the goal is to make your deployments easier, so make sure your applications reflects the different life cycles that your groups of modules might have. If you want to learn more about known patterns, I recommend that you Google OutSystems integration patterns, where you will find a lot of different patterns to deal with external systems. Or if you're already handling a very large factory where you need to segregate different domains of applications supported by different teams, then you can take a look at the OutSystems domain services for some microservices patterns. Okay, we have a version of our architecture done. How can we make sure it is sound? How can we validate the architecture? We can validate it manually by explicitly looking into our applications and modules, but keep in mind that this requires a high level of expertise. We can use the discovery tool, and it will check for the previous mentioned validation rules. I'm not going into details with the discovery tool, but it's actually a pre-requirement to use the architecture dashboard. The discovery tool will automatically classify your modules into the canvas layers, so you don't need to worry about it. But, as everything in life, there are exceptions, so some classifications might be wrong. For instance, if you have a core service but you left some user screens just to test that module, it will probably be identified as an end-user module. You can always use the discovery to reclassify modules. Another alternative is to adopt naming conventions. For instance, if your module has the suffix CS, then it would be classified as a core module no matter its content. Our favorite method, once you have everything correctly classified, is to use the architecture dashboard. So these are not exclusive ways, and typically discovery is used together with the architecture dashboard, because some of the recommendations coming out from the architecture dashboard will require to analyze dependencies among modules or applications that the discovery tool gives the correct support. In the future, the architecture dashboard will also cover that aspect, but for now, resort to the discovery tool whenever necessary. So let me introduce you the architecture dashboard. This tool will support development teams by displaying complex cross-portfolio architectures, identifying problem areas, and promoting intelligent refactoring for scale, reuse, and flexibility. The main benefits are the reduction of technical debt. Using the tool consistently throughout the project will prevent the piling up of small errors that can lead to a big problem down the road. The second advantage is enablement. The architecture dashboard will provide quick and direct guidance for developers to abide by the best practices in a self-sufficient way, speeding up their learning rate and overall code quality. Who is the architecture dashboard designed for? Actually, the entire development team. Architects that need to understand how the architecture is evolving, team leads that need to make sure there are no problems with the solution they are providing, and developers that need to make sure their code adheres to the best practices and doesn't bring any performance, security, or maintenance issue. So let's now introduce the architecture dashboard with a demo. In your browser, access architecture.outsystems.com and use your OutSystems community credentials to log in. What you see here is a heat map with the technical depth of your end-user applications, your core applications, and your foundation applications. The higher the number of issues found in one module, the higher is its technical depth. And that is represented in this range of colors from dark red, orange, light green, and green, from higher technical depth to lower technical depth. In this small graphic below, you can see the evolution of your technical depth. If you zoom in, you can check the evolution day by day. If you just want to check the technical depth of a specific team, then you can filter by team. For instance, let me pick the financial team. And now I only see the applications developed by this team and the evolution of the technical depth of this team. Selecting one application will highlight the dependencies of that application, and in the future it will be possible to see the details of these relations. In this button I can see that the selected application has 3 modules inside. I can click it to see the modules, or I can double click the application itself to drill down to its modules. Now I'm seeing the module canvas of this application, which has an end-user module and 2 core modules. I am now going to select this red module, and I am going to open a report to check what is causing so much technical debt. And this report is showing an extensive list of findings for this module, and each line is a pattern from a certain category with multiple occurrences of that finding. Categories of findings can be architecture, performance, security, or maintainability. Let's filter by architecture. There are 10 public entities that are not exposed read-only, one end-user module providing services, and a monolith web module with too many user interfaces. Let's check these 10 occurrences of public entities not exposed read-only. For each pattern, there is an explanation about its impact and an explanation on how to fix it. You can get the exact path to each occurrence, in this case the product picture entity inside the order management module, or you can immediately open it in Service Studio. Let me log in to the correct environment. It is now downloading the module. And it's now positioned in the product picture entity, and I can now fix the issue. Once I publish the module, the issue will be gone next time Architecture Dashboard synchronizes with your environment, which by default is twice a day. Meanwhile, I can mark this finding as resolved. If you don't mark it as resolved, TrustAdvisor will do it automatically next time it syncs with your environment. You have other options. You can mark a finding as a false positive with a justification, or for instance, you can decide not to fix it at all and then provide a reason. Now that we have seen how architecture dashboard works, let's go back to our exercise architecture and let's simulate a situation where we are checking how does our architecture looks after some development. So here I selected the hospital development team, and you can see that some of these applications are in paler green, meaning that they are producing some technical debt. It's not red, but still it's not the steady green that we see in other applications. Let's see how to find and fix the issues on those applications. I'm going to drill down into the appointment planner, which has only one module. Let's focus on its details. If I drill down on that module, there is one architecture finding. Architecture dashboard found an end-user module providing services. If we expand the impact and how to fix areas, we can now see an explanation what is the real impact of this anti-pattern and how to fix it. So looking into detail to find the solution, the impact is saying that an end-user module is not intended to provide services, and some extra explanation. And the recommendation to fix it is to check the discovery to see which elements are being consumed and then extract those elements and move them to a core or library module according to the concepts. So these are the insights that the architecture dashboard is providing to help you fix the problem. So once we understand the details of the dependencies, we see that there is some reusable logic that is being shared with the doctor app. The solution was to move the consumed logic, in this case the total number of appointments action, which is related with the appointment concept to the appointment business logic. Let's now go to the second paler green application, the hospital core services. This application has 5 modules inside. Let's start by analyzing the Doctor CS. This is a core module that is being consumed by foundation modules. Looking at the details, we can again see the insights of the architecture dashboard to fix it. So before we had this Google Calendar integration service consuming an action get doctor calendar ID, and we also had the SMS notification integration service consuming the doctor's phone number. The way we fix it was to pass the doctor's calendar ID as a parameter to Google Calendar IS logic and also pass the doctor phone number as a parameter of SMS notification IS, and that fixes the issue. Our third finding that we will follow is the fact that there are cyclic references between modules. And this cyclic reference is between the Doctor CS, because we are positioning in the Doctor CS module, and if you position in the Appointment BL module, you will see that there is also a report of a cyclic reference. Again, we can analyze the insights from architecture dashboard just to find out that the Doctor CS is using an action from the Appointment BL. The reason for that is that Dr. CS is exposing a method to set a doctor as absent, and for that he needs to call a method from appointment BL to update the appointment. It's important to understand the conceptual relations among modules to pick the correct reference to break. In this case, appointments are supposed to depend on doctors and they have composition logic, but the Dr. CS module should not be aware of the appointment logic. In this case, the solution is to move the setDoctorAbsent logic to the Appointment BL module. So we have inspected all the pale green modules, and if you look into one of the other modules, you will see that there are no findings. Good job. And the same happens with the Patient CS and the Exam CS. So now that we have fixed everything, how does it look now? Everything is dark green. Good job! How can you start using the architecture dashboard if you haven't done so far? Just check the documentation. Simple Google Introduction to Architecture Dashboard and you will access all the information you need to start using it. So let us wrap up what we learned today. Being fully aligned with the business, first and foremost, is key to make sure that your architecture correctly translates the organization goals to enable the evolution of your applications and promote the correct abstraction and reusage of services. The architecture canvas principles are a well-proven framework to ensure that you are adopting the best practices and your design can scale and evolve with the constant digital transformation of your organization. And finally, keep monitoring the architecture dashboard findings and follow its recommendations to control your technical debt and learn the OutSystems best practices that will keep you growing in a healthy way. Thank you very much for your attention. And now back to Katerina.
That was great. Thank you so much, Francisco. Please note that this will be available on demand and sent to you via email from On24 after today's session. If you are interested in attending our future Tech Talks, please use the link in the resources section to register for the upcoming sessions. We hope you have a great rest of your day.